All right, this is AI project number 3. I'm here to show off variable elimination. So our variable elimination process is kind of complicated. It's buried in a bunch of codes in our variable elimination solver. So what I've done is I've kind of breaking out the process into this method here, this example VE process. And this will kind of show you the simple steps that we go through to do the variable elimination. This variable elimination right here is based off of the earthquake burglary network, and it's a network I wrote in a BIF file off to the side. First thing we do is we make a factor for each of the nodes in the graph. And these factors, think of them as kind of like functions that allow you to get probabilities out of a matrix based on certain evidence. So based on the evidence it'll give you a wider and wider matrix. That way, slowly and slowly, we give it more and more evidence by summing out, and we eventually are left with one number, which is the probability. Then we multiply those and then summate them out, all the way up until we're left with our final distribution. As you can see here, we make all those, and then we make those factor summations. Now, this is a representation of the summation with a bunch of other of the factors in it. You can see here, factor 2 and 3, and earthquake. So this is a summation over the variable of earthquake with these two factors. And we do that because those two factors require earthquake as evidence. And then we do the same thing for F7. It's another factor summation with the remaining, except for F1, because it's not, we already know what burglary is, because burglary is what we're trying to get out of it. So we can see what its probability is at true and at false. So we basically know that already. And then we get those factor summations. And then what we have to do is we have to create our evidence. And we have an evidence where burglary is true and one where burglary is false. You can see that at the end here. Burglary is true, burglary is false. And basically, what we're doing is we're querying what's the probability if it's true and what's the probability if it's false, specifically. If we do both of those, we end up getting a total distribution. Perfect. And then these right here, these f1.solve, they actually return our unnormalized value. So right after we get our unnormalized values for true and false, we normalize them by getting the summation of those two, and then we divide the unnormalized value by the normalized value. All right, so I'm going to run this code, and you'll see that, yep, our final values are 0.2841, so that's like a 28% chance of being true and a 71%-ish chance of being false. If you look at the table, or if you look in the book, following this example, those are the correct values for it. That's basically the process we go through. This is the code where we go through that right here. There's a bunch of other tidbits like our equations and stuff like that, but other than that, that's how our variable elimination works.
Okay, so here's the Gibbs sampling algorithm. Let me just run this real quick. And now, as you can see, these are the outputs for all the various networks that we were running this algorithm on. And you can see that they are the probabilities for all the various values. And you can notice that they have been normalized, meaning that they all add up to 1. Now, how this happens is with the Gibbs sampling that takes in a query, it finds the Markov blanket, which are all the important relevant nodes based on the query. It uses this to create an initial state, a starting state. The starting state is initialized randomly, and the starting state is what begins the sampling. And then for the sampling actually occurs many, many times. Here I'm only using 10,000 total samples. And there's 2 sets of samples because there needs to be an initial burning period. And this is to remove any bias in the first X samples, however many we decide we want to burn. I picked a low number to reduce the amount of time the algorithm runs for. For actually sampling, the algorithm chooses a variable, it samples a variable, and then changes the value of that variable. And after doing this, the specified number of times, it counts up all the value occurrences for the queried variable, and then normalizes it. And then that is what is returned when the algorithm finishes, which is what you can see in the output here.